Okay students, so we will be starting the course which is in the 7th semester and as a program elective 2 named as Municipal Solid Waste Management. You have already studied about the basic introduction of solid waste management in the previous course in 6th semester named as Environmental Engineering 2 in Unit 4. So you have a basic idea of all the functional elements, how to manage the solid waste, especially municipal solid waste. But in this course we will go in the details of various activities related to municipal solid waste management. So in Unit 1 we will discuss about sources and types of municipal solid waste, its various characteristics, methods of sampling and characterization, effects of improper disposal of solid waste, public health effects, principle of solid waste management, social and economic aspects, public awareness, role of NGOs. So for study we will consider the textbook Sewage Disposal and Air Pollution Engineering Environmental Engineering Volume 2 by S.K. Garg, and secondly as an important book, Management of Municipal Solid Waste by T.V. Ramachandra, Terry Press. You can buy or you can get it from the NEPTEL courses given by the lecture notes given by T.V. Ramachandra sir from IISc Bangalore. And as a reference book, or you can say a manual, you can use Manual on Municipal Solid Waste Management by Central Public Health and Environmental Engineering Organization, Ministry of Urban Development, Government of India. This manual is also freely available in PDF form from you can search it from Ministry of Urban Development website. So let's go into the technical points. So what is solid waste? Solid waste are all type of waste arising from human and animal activities that are normally solid in form and that are discarded as useless or unwanted. So unwanted and useless things which are in solid form and produced from or generated from human and animal activities, especially human activities. So it may be organic in nature, may be inorganic in nature, produced from a community or society, and which doesn't carry any value to first user. It means when we are buying a solid thing or we are buying any product, when we are using and afterwards we are discarding this product or item or thing after some time. So after using it, we doesn't value that particular product or item. So at that time it will called it as waste if in solid form, so solid waste, and to me or to us. But it may vary, it may carry some value to the second or third user, that we will see or discuss in few more slides afterwards. So it may be heterogeneous, various characteristics, heterogeneous type from urban areas and homogeneous from a particular area, like from agricultural area, from farming areas, or from particular industry, and within industry also textile industry, will produce some particular type of cloth or oven non-oven type of waste from textile industry only, and from petrochemical industry the type of waste may be solid or may be liquid form, and they may be hazardous chemical compounds. So homogeneous, if we call it as homogeneous waste, then it will be from a particular type of area, and heterogeneous from a bigger area like urban or from rural area. Kitchen refuse, some example: kitchen refuse, paper, product package, maybe grass, cuttings, furniture, wooden furniture, maybe steel or wrought iron furniture, clothing, plastic bottles, batteries, construction and demolition waste, etc. So all are in solid form. Now the solid waste are classified into two types: source based and type based. First, here we will discuss the source based classification. Like, first one is residential. So houses, from our houses, apartments, they are producing some residential waste, like they may be of different types, like leftover foods, vegetable waste, vegetable peels, maybe plastic, dust, clothes, etc. But we are focusing here on the sources. Next source is commercial, maybe markets, maybe hotel, maybe medical shops or establishments, restaurants, etc. And they are producing like food waste, glasses, metals, sachets, maybe some dust, and markets from clothes from markets, medical waste, etc. Institutional, like educational institute, offices, administrative offices, public establishments, they are producing paper, glasses, leftover, some portion of leftover food, plastic in small quantity, etc. Now municipal waste. So municipal activities are will be considered here, like STP means sewage treatment plant, construction and demolition activity, street cleaning, landscaping, etc. And from these activities, dust, building debris, construction demolition waste, waste sludge from STP, leaves from landscaping and street cleaning, etc. will be produced. From industry, process wastes, ash, hazardous chemical compounds, like I told before, construction and demolition wastes, these are the types of waste that will produce from industry, and from different industry the waste type of wastes will be different. Agricultural, rotten food grains, vegetables, agricultural remains, litter, if we are littering the agricultural residues, then the litter, ash, etc. will produce from agricultural activities or agricultural areas from farming. Now type based classification. So this type of classification has a you can say that it will explain it in better way and with extra examples, like garbage. Garbage means animal and vegetable waste from handling, sale, storage, cooking of food. Putrescible, organic matter, obnoxious smell, will evolve from this type of garbage, from animal waste or from vegetable waste. Next is ashes and residues. So ash will generate after burning only. So remaining from burning of wood, if are using coal, charcoal, any combustible material, ash will produce. Produced in larger quantity in industries and plants, called as industrial waste also, and it is inorganic in nature, not organic. Organic is garbage. Combustible and non-combustible from houses, institutions, excluding food waste. Food waste is a separate type of waste which is organic matter. So combustible and non-combustible waste can be generated from houses, institutions, offices, excluding food waste and highly putrescible wastes like paper, textile, rubber, etc. And non-combustible are glass, crockery items, waste items, tin, aluminium waste, ferrous, iron items, and dirt also. Now street wastes. It may be paper, it may be plastic, maybe some wrapper, cardboard, leaves, vegetable waste, litters, etc. Bulky waste. Bulky waste is another separate type of waste, like household appliances. If old TV or refrigerator, washing machines, parts of these also, furniture, vehicle parts, tree cutting, etc. are bulky wastes. Dead animals. Dead naturally or maybe accidentally, but the body of dead animals or body parts of dead animals. Not from slaughterhouses. Slaughterhouses are separated as industrial waste from slaughterhouse industry. Abandoned vehicles like automobiles or trucks are left on public places. We have seen in very commonly in various places. These have scrap value for metals. So if we consider this abandoned vehicle and their parts also for recycling and recovery, we will get some money or revenue, and thus some industry can flourish their activities. Sewage waste will give some solid byproduct like waste sludge we have seen in environmental engineering part 2 from sewage treatment plants, mostly organic, because if we use this sludge after some conditioning and dewatering, we will use it as manure or fertilizer. So treated sludge useful as soil conditioner or soil fertilizer. Biodegradable and non-biodegradable. Likewise, type of wastes are classified in biodegradable and non-biodegradable. Organic matter is biodegradable, food, vegetable waste, paper, wood, but their biodegradation time will be different. And non-biodegradable are inorganic wastes like plastic, glass or crockery or tin or aluminium, and they are recyclable also, plastic, glass, metals, etc. Construction and demolition wastes. So from this particular typical type of construction and demolition activities, some earth material, maybe soil, maybe broken brick, some aggregates, stones, concrete parts, from roofing material, plumbing material like pipes or PVC pipes or cast iron pipes, and joints, various types of joints, electrical parts, etc. will be produced. Hazardous waste will depend on different type of industry, and institutions may be dangerous immediately or over some time for environment. So containers of paints and pesticides etc. will also be considered as hazardous waste, but we are using this container of paint container or pesticide container in our houses for painting and pesticides for agricultural purpose, but these are categorized as hazardous wastes. Some biomedical waste are generated from hospitals, nursing homes, maybe private, maybe government, pathological labs or centers, and these are now categorized as separate type of uh, wastes. E-waste means electronic waste, parts of electronic parts of circuits of from TV, refrigerator or electronic devices are also categorized. And for this biomedical waste, e-waste and plastic waste also, government of India has recommended some rules and regulations for different these types of waste, for us also, for the generators of waste and who are handling these types of waste. So there are different types of rules and regulations and guidelines for management of different types of wastes. Now here is a diagram which is referring the waste generation process with the material flow. How the material is will manufacture a product or item, and how wastes are generation from this material flow. So first, raw material is used for manufacturing any type of product. So raw material, if we screen out or if we take out the good portion of the raw material which we will be using for manufacturing of a product, some residue waste will be generated, maybe some more in quantity or maybe less, but some residual waste surely will be produced. So first step is waste material is produced. Second is manufacturing. Now in the second step, at the manufacturing of any product or item, some residual waste will also be generated. So at the second step also some waste is generated. Now coming to the manufacturing, the next step from the manufacturing to the customer, and the product is going to the customer for use. Here direct, and the customer, from here customer or consumer will use the product and some waste material will also be generated. So here it is also showing that some processing and recovery. So manufacturing, and from if there is present intermediate step like secondary manufacturing, some waste material will also be generated, and these waste materials will go to the final disposal point. So from secondary manufacturing, the product will go to the customer or consumer, and from direct from manufacturing, first step of manufacturing, it will also go to the consumer. Here processing and recovery of some items or products or raw materials, here also this will connect with manufacturing process, and here it is shown from consumer point to the processing and recovery process. Dotted is shown. Dotted means waste material. So consumer is using the products and generating some waste material, and it will go through some processing and recovery, and from here the waste material is converted into some product. So it is shown here in farm line by manufacturing process, and from processing and recovery units, some waste material will also be generated. Not all the waste material will be converted into some product. Some waste is also be generated, then it will also go to the final disposal point. So all the waste materials from processing and recovery, also maybe from secondary manufacturing, maybe consumer point, residual waste, also all the waste material will go to the final disposal point. Now here is a chart, a table which is showing the types of waste, different types of waste and their degeneration time. Degeneration means breakup time, or you can say it dissolution time, or biodegradation time if it is in biodegradable nature. So first one is organic waste, biodegradable nature, vegetable or fruit wastes, leftover food stubs, etc., etc. These will degenerate, it will break up, and rotten form will occur in a week or two, maybe less than this week time. Paper 10 to 30 days, cotton cloth 2 to 5 months, and wood 10 to 15 years. Woolen items, we generally see that we are using woolen items, and they may be 1 year or 2 years they will degenerate and form a unused type of clothing. Tin, aluminium and other metal items such as cans, etc. will degenerate in 100 to 500 years. Plastic bags 1 million years, maybe 1 million years, maybe more than 1 million years. Glass bottles undetermined. The studies have shown that glass bottles take unlimited time, undetermined time for degeneration. So if we consider the recovery or the recycling of especially paper or maybe metal items or plastic or glass or crockery items, we will be in a beneficial position to generate some revenue or money also, and business can be started based on this recycling process. Now, what is the scenario in Indian cities or towns? And some issues have been discussed here, like changing lifestyle of people, unplanned development activities, urbanization development, industrialization. The waste quantity and characteristics are of different types. These are the main causes of the critical problem in Indian cities and towns. The per capita generation rate is about half a kg per day. Per capita means per head, but it is growing. It is not fixed 500 gram or half a kg. In 2010, it has been estimated, and it is changed to 600 gram per day. Studies reveal that the percentage of organic matter has remained almost static, 41% or 40 to 45% in a range in the last 3 decades, 30 years. But the recyclables like paper, plastic, glass waste or metal wastes have increased from 9.56% to 17%. So we have to focus on the recycling facilities. About 90% of municipal solid waste collected by the authorities in India, and after collection it is dumped in low-lying areas outside the city, far away from the city or town, which have no provision of leachate collection and treatment or landfill gas collection and use. So 90% is collected but not used or recovered or properly treated with leachate management or landfill gas. Well, leachate is a liquid waste from landfill area, and landfill gases are of course a gaseous you can say problem which can evolve, which evolved mainly methane in 50 to or 70% of total gas, which can be collected and reused. As a result, leachate containing heavy metals, because it is a liquid waste, it contains heavy metals, finds its way to the underground water. So underground water will be unfit for drinking if we are taking it or pumping out. Landfill gas escapes into atmosphere, adding to greenhouse gas emissions. Contaminated leachate and surface runoff from the land disposal facilities affects also the ground and surface water quality. It is estimated that 40 to 80% of plastic wastes get recycled in India, as compared to 10 to 15% in the developed nations of the world. At the dump sites in the city of Mumbai, 95 workers were examined. A case study is shown here, discussed here. In the city of Mumbai, 95 workers were examined, and it was found that 80% of them had eye problems, maybe respiratory problems, gastrointestinal ailments, means intestine problem, diseases, and skin problems also 27%. Studies among 180 rag pickers has been done in Calcutta city at open dumping sites, and it reveals that average quarterly incidence of diarrhea, which is an intestinal problem, was 85%, fever 72%, cough and cold 63%. The pneumonic plague that broke out in November 1994 in India, Surat, is a typical example of solid waste mismanagement. And the last Mumbai case study and Kolkata case study gives us a glimpse of health problem or ill effects of solid waste mismanagement on the health of the workers who are handling the wastes. Now, factors affecting the generation of wastes. So first point is geographic location. It is related to different climates that influences both the amount of solid waste and the nature also. So for different climate, like summer, maybe rainy season, or maybe winter, it will influence the amount, means the quantity of solid waste generated, and the collection operation also influences. Major variations in the amount of garden waste generated in various parts of India are related to the climate. Like an example is given here, like in the warmer southern areas, the South India, where the growing season is considerably longer compared to the northern areas, garden waste are collected in considerably larger quantities and over a long period of time. Seasons have implications for the quantities and composition of types of solid waste. Like for growing season of vegetables and fruits, that affect the quantity of food waste also. Collection frequency, where there are ultimate collection services, more wastes are collected. Example is, if a resident has access to only 1 or 2 containers per week, due to limited container capacity, he will store some plastic or paper, newspapers, or other packaging materials in some specified separate storage area. The person will tend to throw waste if there is access to unlimited container services. So we will not think about that what type of waste we should throw away. In this situation, the quantity of waste generated may actually be the same. Quantity generated is same, but the quantity collected by the authority will be different as it relates to the frequency collection. Population diversity. Different types of population people influence the quantity and composition of waste. Amount of waste generated is more in low income areas compared to that in high income areas. Composition will also differ in case of paper and recyclable materials or wastes, which are typically more in high income areas or high income people rather than low income people. Extent of salvaging and recycling. The existence of preserve and cycling operations within a community affects the quantity of waste collected also. If there is an recycling point, so the quantity of waste will be less. Generated is same, but the quantity of waste collected will be separated. Some portion will go to the recycling point and some portion will go to the maybe composting point or maybe some metal industry, or some portion will go to the landfill for final disposal. Public attitude. Reduction in quantity is possible. So quantity generated, in reduction in the quantity generation is possible if and when people are willing to change their own habits and psychology also and lifestyles to conserve the natural resources and to reduce the expenses involved with the management of solid waste. Legislation or policies or rules and regulations. So local and state regulations concerning the use and also disposal of specific type of materials or wastes is important, which influences the composition and generation of specific types of wastes. So now we are going to discuss waste characteristics. So waste characteristics are basically categorized as physical and chemical. Physical character, to determine the physical characteristics. Why it is important? It is important for selection and operation of the equipment, for further treatment, for further process or recovery, and for the analysis and design of disposal facilities. And chemical composition we have to determine, we have to know, because the products of decomposition and heating values means if certain type of solid wastes are having carbon content or some hydrogen and nitrogen and sulfur content, some waste during processing or treatment or recovery, some waste will, some maybe gases or maybe liquid waste will be generated. So to know about the liquid or gaseous waste, we have to first chemical analysis we have to do, we have to determine, and also the energy values or heating values. Solid waste are to be used, can be used as fuel if we know their heating values are proper, or calorific content. Technically it is known as calorific value or calorific content, and are used for any other purposes. So first, physical property or characteristics is density. Density of waste is a critical factor in design of sanitary landfill or for storage containers, storage facilities, type of collections, so collection vehicle, the volume of collection vehicle and transport vehicles. Efficient landfill operation requires compaction of waste to optimum density. So if we simply not landfill or dump the waste, if we want to consider the landfill area as with its optimum use or efficient use, we have to bring down the density, or we have to densify actually the waste to its optimum point. So compaction is needed. Any normal compaction equipment can achieve reduction in volume of waste, so it will densify then, up to 75%. Example like waste collection vehicle can haul 4 times the weight of waste in its compacted state than when it is not compacted. So when it is not compacted, it will be heavy in volume, and then when it is in compacted state, it will be densified, so it will haul, or it will cover 4 times the weight of the waste. Changes in density occur as the waste moves from source to disposal, then due to scavenging, maybe handling, maybe some weathering actions, vibration of collection vehicles, and decomposition, etc. So if this waste moves from source to the final disposal point, some portion of the waste, not the whole portion, it will naturally gets changes in the physical property like density. So for determining the density of waste, cubical container of 60 by 60 by 60 centimeter or any known volume, maybe you can take it maybe 50 centimeter, volume should be known, is taken and empty weight is recorded. Solid waste is filled to overflow in the cubical container. Then compaction is done by tamping the container thrice. For compaction, container is lifted up 6 cm above the ground and dropping down squarely. The top of the container is then leveled with the help of straight edge, and finally the container is weighed. So density will be weight of container filled with solid waste minus the empty weight. So we will get the weight of solid waste divided by the volume of the container. Now moisture content. So ratio of the weight of not water, it will be waste, weight of water to the total weight of wet waste. Like weight of the waste minus dry weight of the waste. So moisture increases, if we clarify it, moisture increases with the weight of solid waste, and the cost of collection will that over hauling time and hauling weight. So the cost of collection and transport will also be increases. It is a critical factor in the economic feasibility of waste management or treatment by incineration, because if it is a wet type of waste, it consumes more energy for evaporation or for burning out in the incinerator and in raising the temperature of water vapor. So energy will be consumed more if we are using wet type of waste. Waste should be insulated from rainfall. When we are collecting or we are keeping it in a storage container, the moisture should be not get introduced, or rainfall from it should be insulated from rainfall. Wet waste can be dried at 105 degrees Celsius. So moisture content, if we want to determine weight of waste minus dry weight of waste into 100 divided by weight of the waste. Number 3 is size. How it is concerned in the waste management or for treatment purpose also. Measurement of size distribution, or you can say it as particle size distribution, waste size distribution of waste particles, it is important for the design of recovery of materials and for mechanical treatment like separators or for shredders. If we want to separate different types of waste as per their particle size, and for shredding also, for cutting also. So size of the component, SC size of the component, if we are having only one chance to measure the size in length. So size of the component will be simply in length in millimeter or centimeter. If we have length and width, then length plus width divided by 2, so average size. And if we have the height of the component or waste, then L plus W plus H divided by 3. So in this case also average size of the component or particular waste we will get. Now it is going some different type of characteristics or parameters like field capacity. The field capacity of municipal solid waste is the total amount of moisture. Field capacity, actually we know for moisture, it is related to moisture content which can be retained in the waste sample subject to gravitational pull. It is a critical measure because water in excess of field capacity will generate leachate, which is a hazardous liquid form of waste, which is major problem in landfill. Field capacity varies with the degree of applied pressure and the state of decomposition of the waste. Field capacity of residential and commercial sources waste, actually sources from waste, are in the range of 50 to 60%. Now permeability of compacted waste. Hydraulic conductivity of compacted waste is an important physical property. It governs the movement of liquids and gases in a landfill. So the permeability of compacted waste will affect the movement of liquid, means leachate here, and the landfill gases. Permeability depends on other properties of the solid waste material like pore size distribution, surface area, and porosity also. So regarding to the porosity, the amount of voids per unit overall volume of the material or the waste. The porosity of municipal solid wastes varies typically from 0.4 to 0.67 depending on the compaction and the composition of the wastes. Porosity of solid waste N equals to E by 1 plus E, where E is the void ratio of the waste. Compressibility, we are talking about compaction. So degree of physical changes of the suspended solid or waste, cakes, or simply waste materials, dump of waste when subjected to pressure. So delta HD, total settlement, is equals to delta HI, immediate settlement plus HC consolidation settlement plus H alpha, secondary settlement or secondary compression or creep. So all these parameters or physical properties from density to porosity and compressibility, this will affect the processing, maybe mechanical processing or maybe organically biodegradable treatment of waste, or maybe disposal to the landfills. Here is a table which shows different types of waste on the leftmost column, from food waste to dirt, ash, bricks, maybe organic and then maybe inorganic, recyclable also. Their mass in percentage, mass or weight in percentage range and typical values, moisture content with typical values and the typical values of density in kg per meter. We can, for estimation of any treatment or processing, or how much quantity of leachate or gases will be generated, we can take some typical values from this table also. Thank you.